Though cold and often remote, the icy reaches of the Arctic, Antarctic, and other frozen places affect the lives of everyone on Earth. We start our tour in Antarctica. The vast blankets of ice covering the southernmost continent contain 70% of the world's fresh water. But Antarctica is one of the driest places in the world. Clouds there generally consist of ice crystals and very little water. Approaching the South Pole, radar illuminates the runway, the only way for scientists to get into or out of this frozen laboratory. It's so cold here that even small amounts of annual snowfall pile up into glacial ice. Glaciers and ice streams carry ice from the interior of the continent out to the ocean. At the edges, glaciers often converge into gigantic floating ice shelves. The largest of these, the Ross Ice Shelf, is the size of France. Where they meet the sea, mountains of ice crack and crumble. The resulting icebergs can float for years. Ice shelves surround half the continent. They slow the relentless march of ice streams and glaciers like dams hold back rivers. But the region is changing. As temperatures increase, we see a growing number of melt ponds. As this heavy meltwater forces its way into cracks, ice shelves weaken and can ultimately collapse. After 12,000 years, the Larsen B ice shelf collapsed in just 5 weeks. Offshore, sea ice forms when the surface of the ocean freezes, pushing salt out of the ice. The cold, salty surface water starts to sink, pumping deeper water out of the way, powering global ocean circulation. These currents influence climate worldwide. Most ice exists in the cold polar regions, but we see glaciers like these in the Andes all over the world. Most are shrinking. Here in North America, millions of people experience the cryosphere every year. Eastward moving storms deposit snow like thick paint brushes. Mountain snowpacks store water. Snowmelt provides 3/4 of the water resources used in the American West. Substantial winter snows produced a green Colorado in 2003, but drier conditions the previous year limited vegetation growth and increased the risk of fires. In the Rocky Mountains, there are patches of frozen ground called permafrost that never thaw. These regions are unusual in the mid-latitudes, but farther north, permafrost is more widespread and continuous, covering nearly 1/5 of the land surface in the northern hemisphere. Because the poles are covered with snow and ice, they help regulate our planet's temperature. Snow, ice, and clouds reflect significant amounts of sunlight, helping to keep the planet cool. In contrast, open water absorbs most of the sunlight that reaches it, a process that heats the Earth. By comparing measurements of reflected and absorbed sunlight, scientists can determine where the Earth is heating and where it's cooling. The ice-covered poles play a significant role in cooling the Earth. Sea ice varies from season to season and from year to year. Data show that Arctic sea ice has shrunk dramatically in the last few decades. The effects could be profound. As polar ice decreases, more open water could promote greater heating. More heating could lead to faster melting, reinforcing the cycle. If this trend continues, the Arctic Ocean could be ice-free in the summer by the end of the century. These changes in ice cover are not limited to oceans. Greenland's ice sheet contains nearly 10% of the Earth's glacial ice. Glaciers in western Greenland produce most of the icebergs in the North Atlantic. After decades of stability, Greenland's Jakobshavn ice stream, one of the fastest flowing glaciers in the world, has changed dramatically. The ice has thinned and the front retreated significantly. Between 1997 and 2003, the glacier's flow rate nearly doubled to 5 feet an hour. These are just some of the cryospheric processes that NASA satellites observe from space. Continued observation provides a critical global perspective as our home planet continues to change day to day, year to year, and further into the future.